Welcome to Daily Podcast, the future of intelligence. Today, we're diving into the fascinating world of portfolio optimization, specifically focusing on the hierarchical risk parity algorithm, or HRP for short.
Oh, HRP is such a game changer in financial machine learning. It's like the cool, modern cousin of the old-school critical line algorithm, or CLA, which has been around since Harry Markowitz introduced it.
Exactly. CLA was revolutionary for its time, but it's got some serious flaws, right? It's super unstable because it relies on inverting that covariance matrix. One tiny market hiccup, and the whole thing goes haywire.
Yeah, and don't even get me started on estimating stock returns. It's like trying to predict the weather with a broken thermometer, super unreliable. Plus, CLA is computationally expensive. It's like running a marathon just to get your portfolio weights.
Right? And then there's the hierarchy loss. CLA treats every asset like it's interchangeable, but in reality, not all assets are equally correlated. That's where HRP steps in. It actually respects the natural hierarchy of assets.
Oh, absolutely. HRP breaks it down into three key steps: hierarchical tree clustering, matrix seriation, and recursive bisection. It's like building a family tree for your investments, figuring out who's related to whom, and then assigning weights accordingly.
Wait, let's unpack that a bit. So, hierarchical tree clustering, that's where you group assets based on their correlations, right? Like, you're clustering stocks that move together in the market.
Exactly. You start with a correlation matrix, convert it to a distance matrix, and then recursively cluster assets until you've got this big, interconnected tree. It's like organizing your closet by color and style. Everything just makes more sense.
Got it. And then matrix seriation. That's where you rearrange the covariance matrix to highlight those clusters, right? So, similar assets are grouped together, and the matrix becomes quasi-diagonal.
Bingo. It's like rearranging puzzle pieces so you can see the big picture. And then comes the recursive bisection. That's where the magic happens. You start assigning weights to those clusters, working your way down the tree.
Oh, that's where HRP really shines. It's not just throwing weights around randomly, it's methodical. It balances the portfolio by considering the variance of each cluster and adjusting weights accordingly.
Yeah, and the best part? HRP is way more stable than CLA. When the market throws a curveball, HRP doesn't freak out. It rebalances smoothly, spreading the risk across correlated assets. It's like having a financial shock absorber.
Totally. And compared to something like inverse variance allocation, which just spreads weights uniformly, HRP is way smarter. It gives more weight to the top performers, but still keeps the portfolio diversified.
Exactly. HRP finds that sweet spot between CLA's extreme concentration and IVP's overly cautious approach. It's like Goldilocks, just right.
And let's not forget how HRP handles random market shocks. When you add noise to the covariance matrix, CLA goes haywire, but HRP stays calm and rebalances intelligently. It's like it's got a built-in stress management system.
Oh, for sure. CLA might increase weights on assets that should be reduced, but HRP? It's like, nope, I've got this. It's robust, fast, and flexible. Everything you want in a portfolio optimization algorithm.
So, to wrap it up, HRP is basically the future of portfolio optimization. It addresses all the shortcomings of CLA and IVP, and it's practical enough to use in real-world scenarios.
Absolutely. It's not just theoretical, it's actionable. And with the rise of financial machine learning, HRP is only going to get better. It's an exciting time for portfolio management.
So, let's dive deeper into the computational expense of CLA. You mentioned it's like running a marathon just to get portfolio weights. Why is that?
Oh, it's because CLA has to calculate the inverse of the correlation matrix. And when you're dealing with a large portfolio, that matrix can get huge. Every single edge in the connected graph of assets has to be considered, which is a massive computational burden.
Right, and that's not just time-consuming. It's also prone to instability. One wrong move, and the whole thing collapses, right?
Exactly. It's like building a house of cards in a windstorm. If the market shifts even slightly, CLA might spit out weights that make no sense. And don't even get me started on the hierarchy loss.
Oh, yeah. That's where CLA treats all assets as if they're interchangeable. even though they're not. It's like saying apples and oranges are the same because they're both fruit.
Exactly. CLA ignores the natural hierarchy of assets. Not all assets are equally correlated, and pretending they are just leads to a messy, inefficient portfolio. That's why HRP steps in. It respects those relationships.
So, HRP starts with hierarchical tree clustering. How does that work exactly?
Well, it's like organizing a family reunion. You start by grouping assets that are closely related, stocks that move together in the market. You build a tree, or a dendrogram, that shows how these assets are connected. It's all about understanding the structure of your portfolio.
Got it. And then comes matrix seriation, right? That's where you rearrange the covariance matrix to highlight those clusters.
Yes. It's like rearranging a messy desk so you can see everything clearly. You take that covariance matrix and reorganize it so that similar assets are grouped together. The matrix becomes quasi-diagonal, which makes it easier to work with.
And then the recursive bisection. That's where the real magic happens, isn't it?
Oh, absolutely. You start at the top of the tree and work your way down, assigning weights to each cluster based on their variance. It's methodical, precise, and, most importantly, stable. Even if the market throws a curveball, HRP adjusts smoothly.
That's what makes it so practical, right? It's not just theoretical, it's built for real-world chaos.
Exactly. HRP is like a financial shock absorber. It doesn't freak out when things get noisy. It just recalibrates and keeps going. And compared to CLA, it's way faster and more reliable.
So, to sum it up, HRP is the future because it's robust, flexible, and actually respects the natural structure of the market.
Absolutely. It's not just an improvement. It's a revolution in portfolio optimization. And with financial machine learning evolving, HRP is only going to get smarter.
Okay, so let's break this down step by step. First, we've got the correlation matrix, right? That's where we calculate how each stock's returns correlate with every other stock in the portfolio. It's like mapping out who's friends with whom in the stock market.
Yeah, exactly. You end up with this matrix, which is essentially a snapshot of how these stocks move together or don't. It's the foundation for everything that comes next.
Got it. And then we convert that correlation matrix into a correlation distance matrix. That's where the formula $D equals 0.5 times SQRT1 rho dollar comes in, right? What's the intuition behind that?
Oh, it's all about translating correlation into a measure of distance. The closer the correlation is to 1, the smaller the distance, meaning those stocks are practically twins. But if the correlation drops, the distance grows, like, hey, these two don't really hang out.
So it's a way to quantify how far apart these stocks are in terms of their behavior. And then we take that distance matrix and calculate another one, $bar D underscore IJ dollar, using Euclidean distance. That's where things get really mathematical, huh?
Yeah, but it's not as scary as it sounds. You're just comparing the columns of the distance matrix pairwise, squaring the differences, and summing them up. It's like measuring how much each stock's distance profile differs from the others. The bigger the number, the more unique the stock's behavior.
Okay, so once we've got that, we start forming clusters. The first cluster is formed by finding the pair of stocks with the smallest distance, right? Like, $U equals /arg/ min /bar D dollar.
Exactly. It's like saying, hey, these two stocks are practically inseparable. Let's group them together. And then you repeat the process, building up this hierarchical tree of clusters. It's like organizing a big, messy family reunion into smaller, more manageable groups.
So, the whole point of this clustering is to respect the natural relationships between assets, right? Unlike CLA, which just treats everything as interchangeable.
Oh, absolutely. CLA's like, they're all just numbers. But HRP? It's like, no, these stocks have relationships. Let's honor that. It's a much smarter way to build a portfolio.
And once we've got these clusters, that's where the recursive bisection comes in, assigning weights based on variance and all that, right?
Yep. You start at the top of the tree and work your way down, balancing the portfolio in a way that makes sense. It's not just throwing darts at a board. It's methodical, precise, and, most importantly, stable.
So, to sum it up, HRP is all about respecting the natural structure of the market, clustering assets intelligently, and then assigning weights in a way that's robust and flexible.
Exactly. It's like giving your portfolio a brain, one that knows how to handle chaos without falling apart. And that's why it's such a game changer.
Okay, so we've got the hierarchical tree clustering done. Assets are grouped based on their correlations. Now, we need to update the distance matrix, right? How does that work?
Oh, yeah. So once you've formed a cluster, you calculate the distance of every other asset to that new cluster. It's like saying, hey, this new group exists. How close is everyone else to it? You're basically redefining the relationships in the portfolio.
Got it. And then you keep doing this recursively, combining assets into clusters and updating the matrix until you've got one big cluster of stocks, right?
Exactly. It's like building a family tree, but for your investments. You start with individual stocks, group them into smaller families, and eventually, you've got this massive, interconnected tree. It's all about understanding the structure of your portfolio.
And then comes matrix seriation. That's where you rearrange the covariance matrix to highlight those clusters, isn't it?
Yes. It's like taking a messy spreadsheet and reorganizing it so that similar stocks are grouped together. You end up with this quasi-diagonal matrix where the larger covariances are along the diagonal and the smaller ones are scattered around. It's a much cleaner way to visualize the relationships.
So, it's not just about making the matrix look pretty. It's about making it functional, right? Like, you're setting the stage for the final step, recursive bisection.
Oh, absolutely. Matrix seriation is like laying the groundwork. It's preparing the data so that when you get to recursive bisection, everything's in the right place. You're not just throwing weights around randomly. You're assigning them based on a clear, logical structure.
And that's where the real magic happens, right? Recursive bisection is where you assign the actual weights to the assets.
Exactly. You start at the top of the tree and work your way down, assigning weights to each cluster based on their variance. It's methodical, precise, and most importantly, stable. Even if the market throws a curveball, HRP adjusts smoothly.
So, it's not just about balancing the portfolio, it's about balancing it intelligently, respecting the natural structure of the market.
Yes, HRP is like giving your portfolio a brain, one that knows how to handle chaos without falling apart. It's not just an improvement over CLA, it's a revolution in portfolio optimization.
And the best part? It's not just theoretical. It's practical, actionable, and built for real-world chaos.
Oh, for sure. HRP is the future of portfolio management. It's robust, flexible, and, let's be honest, just plain smarter than anything that's come before it.
Okay, so we've got this giant cluster after the tree clustering step, and now we're breaking it down into subclusters. How does that work exactly?
Right, so it's all about recursion. You start at the top of the tree, the big cluster, and then you split it into two subclusters. It's like peeling an onion, layer by layer, until you get to the individual assets.
Got it. And you're using the quasi-diagonalized covariance matrix for this, right? That's the one we rearranged earlier to highlight the clusters.
Exactly. The quasi-diagonal matrix is key here. It's like having a map that shows you where the clusters are, so you know exactly where to split. You're not just guessing, you're following the structure.
So, once you've split the cluster, you calculate the variance for each subcluster. That's where $V_AJ equals W to the power of TVW comes in, right?
Yes, you're essentially measuring how much each subcluster varies. The weights, $W, are derived from the trace of the covariance matrix, so you're scaling the variance based on the importance of each asset in the cluster.
Wait, so $W equals \text, diagram \text, trace, $1. That's like normalizing the variance, isn't it?
Oh, yeah. It's a way to ensure that the variance calculation isn't skewed by the size of the cluster. You're giving each asset a fair shot, so to speak.
And then you calculate the weighting factors, $\alpha $1 and $\alpha $2, based on the variances of the subclusters. That's where $\alpha1 equals 1, \frac, V1 plus V2 comes in, right?
Exactly. It's a proportional thing. If one subcluster has a higher variance, it gets a smaller weight, and vice versa. It's all about balancing the risk across the portfolio.
So, the weights of the stocks in each subcluster are updated based on these factors. That's $W1 equals backslash alpha 1 backslash times $W1 and $W2 equals backslash alpha 2 backslash times $W2, right?
Yes. It's a way to ensure that the weights reflect the risk profile of each subcluster. You're not just assigning weights randomly, you're doing it methodically, based on the data.
And this whole process is recursive, right? You keep splitting and updating weights until you've assigned weights to every individual asset.
Exactly. It's like working your way down the tree, assigning weights at each level, until you've got a fully optimized portfolio. It's methodical, precise, and, most importantly, stable.
So, to sum it up, HRP is all about respecting the natural structure of the market, clustering assets intelligently, and then assigning weights in a way that's robust and flexible.
Yes, HRP is like giving your portfolio a brain, one that knows how to handle chaos without falling apart. It's not just an improvement over CLA, it's a revolution in portfolio optimization.
Okay, so we've covered how HRP assigns weights recursively, but let's talk about how it performs compared to other algorithms. Specifically, CLA and IVP. How do they stack up?
Oh, this is where it gets really interesting. CLA, for instance, is super concentrated. Like, 99% of the portfolio is often allocated to just the top 3 assets. It's like putting all your eggs in one basket, except it's 3 baskets, but still, super risky.
Right, and that's because CLA is trying to maximize returns by focusing on the assets with the highest expected performance, right? But it's ignoring everything else, which is not great for diversification.
Exactly. And then there's IVP, inverse variance allocation. It's the opposite extreme. It assigns non-zero weights to all assets, and except for the top 5, the weights are almost uniform. It's like saying, hey, let's spread the risk evenly across the board.
But that's not ideal either, is it? I mean, spreading weights uniformly doesn't account for the actual relationships between assets. It's like treating every stock as if it's equally important, even when it's not.
Oh, absolutely. IVP is safer than CLA, sure, but it's also overly cautious. It doesn't take advantage of the natural hierarchy of assets, like, some stocks are just more correlated than others, and IVP ignores that.
So, where does HRP fit into all this? It's not as extreme as CLA or IVP, right?
Yeah, HRP finds that sweet spot. It doesn't concentrate everything on a few assets like CLA, and it doesn't spread weights uniformly like IVP. Instead, it respects the natural structure of the market, clustering assets based on their correlations and assigning weights accordingly.
So, it's like, CLA is the risk taker, IVP is the cautious one, and HRP is the balanced, thoughtful middle ground.
Exactly. HRP is like the Goldilocks of portfolio optimization, not too hot, not too cold. It's robust, flexible, and it handles market shocks way better than CLA or IVP. It's the future, honestly.
And let's not forget how HRP handles noise in the covariance matrix. CLA goes haywire, IVP stays too rigid, but HRP? It just recalibrates smoothly. It's like it's built for real-world chaos.
Oh, for sure. HRP is designed to adapt. It's not just theoretical, it's practical. And that's why it's such a game changer in portfolio management.
So, to sum it up, HRP outperforms CLA and IVP because it's smarter, more stable, and actually respects the natural structure of the market. It's not just an improvement, it's a revolution.
Absolutely. And with financial machine learning evolving, HRP is only going to get better. It's an exciting time for portfolio optimization.
Okay, so let's dive into how HRP handles rescaling of covariances when you add random noise to mimic market volatility. It's fascinating how it reacts compared to CLA, right?
Oh, absolutely. HRP is like the calm, collected friend who doesn't freak out when things get chaotic. When you add noise to the covariance matrix, HRP doesn't just throw its hands up. It rebalances intelligently.
Right. So, if the allocation for, say, BND goes down because of the shock, HRP doesn't just leave it at that. It spreads that reduction across other correlated investments in the same cluster, like CSJ, IEF, and LQD. It's like, hey, we're in this together.
Exactly. And it doesn't stop there. HRP also increases allocations for uncorrelated investments with lower variances. It's like it's saying, let's not put all our eggs in one basket. Let's diversify even more.
So, it's not just about rebalancing within clusters. It's about looking at the bigger picture and adjusting the entire portfolio to handle the shock. That's what makes it so robust, right?
Oh, for sure. HRP is designed to adapt. It's not just reacting, it's proactively managing risk. And that's where CLA falls flat. CLA? It's like a deer in headlights when the market gets noisy.
Yeah, CLA just goes haywire. It's like, what just happened? Let's increase weights on assets that should probably be reduced. It's so erratic.
Totally. CLA doesn't have that built-in shock absorber like HRP does. It's like trying to drive a car with no suspension. Every bump throws you off course. HRP, on the other hand, smooths out the ride.
And that's why HRP is so practical for real-world scenarios. The market is never perfectly stable, and HRP is built to handle that chaos. It's not just theoretical, it's actionable.
Exactly. HRP is like the Swiss Army knife of portfolio optimization. It's got the tools to handle whatever the market throws at it. And with financial machine learning evolving, it's only going to get better.
So, to sum it up, HRP's ability to rebalance intelligently during market shocks is what sets it apart. It's not just about surviving the chaos, it's about thriving in it.
Absolutely. HRP is the future of portfolio management. It's robust, flexible, and, let's be honest, just plain smarter than anything that's come before it.
Okay, so let's talk about how CLA, IVP, and HRP handle random market shocks. CLA, for instance, goes completely haywire, right? Like, it's not just a little unstable, it's erratic.
Oh, absolutely. CLA's like, oh, the market's noisy? Let's increase weights on assets that should probably be reduced. It's almost comical how badly it reacts.
Yeah, and it's not just a small tweak, it's a massive overcorrection. Like, if BND's allocation should go down, CLA might actually increase it. It's like it's trying to sabotage itself.
Exactly. And that's because CLA doesn't have any built-in mechanism to handle noise. It's like driving a car with no brakes. You're just along for the ride, hoping for the best.
Right. And then there's IVP. It's a bit more stable, but it's still not great. It tends to reduce allocations for the affected investments and spread the change over the unaffected ones, right?
Yeah, but here's the thing. IVP only looks at individual variances. It doesn't consider the covariances between investments. So, it's like, hey, let's spread the risk evenly, but it's not really addressing the underlying relationships.
So, it's kind of like putting a Band-Aid on a broken leg. It's better than nothing, but it's not solving the real problem.
Exactly. And that's where HRP shines. When there's a shock, HRP doesn't just freak out. It rebalances intelligently, spreading the reduction across correlated investments in the same cluster.
Oh, so if BND's allocation goes down, HRP doesn't just leave it at that. It adjusts CSJ, IEF, and LQD too, right? It's like, we're all in this together.
Yes, and it doesn't stop there. HRP also increases allocations for uncorrelated investments with lower variances. It's like it's saying, let's not put all our eggs in one basket. Let's diversify even more.
So, it's not just about rebalancing within clusters. It's about looking at the bigger picture and adjusting the entire portfolio to handle the shock. That's what makes it so robust, right?
Oh, for sure. HRP is designed to adapt. It's not just reacting, it's proactively managing risk. And that's where CLA falls flat. CLA? It's like a deer in headlights when the market gets noisy.
Yeah, CLA just goes haywire. It's like, what just happened? Let's increase weights on assets that should probably be reduced. It's so erratic.
Totally. CLA doesn't have that built-in shock absorber like HRP does. It's like trying to drive a car with no suspension. Every bump throws you off course. HRP, on the other hand, smooths out the ride.
And that's why HRP is so practical for real-world scenarios. The market is never perfectly stable, and HRP is built to handle that chaos. It's not just theoretical, it's actionable.
Exactly. HRP is like the Swiss Army knife of portfolio optimization. It's got the tools to handle whatever the market throws at it. And with financial machine learning evolving, it's only going to get better.
So, to sum it up, HRP's ability to rebalance intelligently during market shocks is what sets it apart. It's not just about surviving the chaos, it's about thriving in it.
Absolutely. HRP is the future of portfolio management. It's robust, flexible, and, let's be honest, just plain smarter than anything that's come before it.
So, let's wrap this up. HRP isn't just fast and robust, it's flexible. It's like the Swiss Army knife of portfolio optimization, right? It adapts to market chaos without breaking a sweat.
Oh, absolutely. It's not just theoretical, it's practical. You can actually use it in real-world scenarios, which is why it's such a game changer. And the fact that it's fast? That's just the cherry on top.
Yeah, speed is huge. CLA feels like running a marathon just to get portfolio weights, but HRP? It's like a sprint, efficient and effective. And let's not forget how it handles noise in the market. CLA freaks out, IVP stays rigid, but HRP? It just recalibrates smoothly.
Exactly. It's like HRP has this built-in stress management system. When the market throws a curveball, it doesn't panic, it just adjusts. That's what makes it so reliable.
And the way it respects the natural hierarchy of assets? That's genius. It's not just treating everything as interchangeable, it's actually understanding the relationships between assets. That's why it outperforms CLA and IVP out of sample.
Oh, for sure. CLA's like, they're all just numbers, and IVP's like, let's spread the risk evenly. But HRP? It's like, no, let's actually think about this. It's methodical, precise, and, let's be honest, just plain smarter.
So, to sum it up, HRP is the future of portfolio optimization. It's fast, robust, flexible, and, most importantly, it works in the real world. It's not just an improvement, it's a revolution.
Absolutely. And with financial machine learning evolving, HRP is only going to get better. It's an exciting time for portfolio management.
Well, that's all the time we have for today. Thanks for joining us on Daily Podcast, The Future of Intelligence.
Thanks for tuning in, everyone. See you next time.